Okay. So nice. Sorry to have you waiting. So just to start, I'm the fab manager at the Fab Lab Fabule. We are located in Rivière-du-Loup, just here, and I live near the river, just there. We have a lot of mosquitoes, and the rest is very nice. Okay, so the idea, I don't pretend to have the best solution about how to make digital fabrication easier. You know that it's a challenge. I want to share my ideas, and mainly I want to hear yours. So maybe together we can make our lab easier. So I'm gonna start. That's it. Okay, a steep learning curve. I'm an industrial designer. I did 4 years at university. I learned graphic arts at college, and I still feel that I need to learn everything. So it's very tough for a newcomer that haven't did that, who is not a maker, to learn how to make things. You know it. I'm not telling you anything new. The newcomer is often naive. You come with a project, mainly, very often. Um, he will need to learn a lot of things, design, apart from the CAD, the design, how to imagine his object. He will need to learn, oops, sorry, software. Well, he will need to learn software, two kinds, in fact, the software that will help me design his part, and the other software that helps the operation of the machine. You will need to learn procedure inherent to the Fab Lab, how to become member, how does it goes, where can I come, when can I come, and so on. Safety rules. You will need to learn a lot about materials, fasteners, where to order it, and the manufacturing processes. So is at the beginning of a huge quest. Let's say it. What's the risk? Oops. No, sorry. I'm coming back here. Here. Well, okay. So what's the risk? In fact, the risk is that the newcomer might, in fact, in French we say throw the towel. He might give up his project. So we might lose a new member. We won't be able to see it again, and of course that newcomer won't become a volunteer. So on my point of view, that's a huge risk on our side. So I want the newcomers to achieve their goals in order for them to come back. And also, we don't want them to make bricolage. I didn't want to translate that word in French. Bricolage means some kind of crafts that kids do at school. It gives great results since they are using very similar material procedures and so on. So they get a nice result, but they can't differ too much from what was the plan, because everything is prepared for them. So on my side, I think that we should not hide the true complexity of things, but also that complexity might make it scary. So that's kind of two-edged blade. We need to keep the balance between those two. Uh, on my side, I think proprietary is easier. Of course, let's talk about the Makerbots, the Mark Forge printer, which are very easy to use, but you're stick with also their equipment, their softwares, their stock, and the newcomer won't learn to become more free from for that. And I think that the main goal of Fab Lab is about teaching freedom. So also it's a two-edged blade. Let's see what we can do. Um, the show must go on. I use that sentence very often at the Fab Lab Fabule. It means that when somebody come at the Fab Lab, I want him to leave the Fab Lab with a result, with what he came from at the first visit. Okay, so I try to make sure that I have different materials so we can sell them. It will be easier for them. Let's say somebody want to do just a small part out of wood. It will be tough to order a huge sheet. He doesn't know where to order it. He doesn't know the sheet will be too big for his car and so on. So we try to keep materials. I think it's a minimum. We try to keep all machines in working conditions. That's very tough on my side. I don't know on your side, but on my side, that's a huge challenge. We try to have the regular member take care of newcomers, and they might be better at vulgarization, at helping them to understand. Also, another idea is to install all software on all computers. It sounds obvious, but on my side, I did it. That's very recently we did it. The purpose is that if one computer is broken or already used or whatever, by the newcomer will be able to continue his project on another computer. Uh, of course, it's a lot of work because you need to have all of them updated at the same time and so on. And finally, keep at least one machine on each OS. I am talking about Windows, Linux, and Mac OS because you will always have somebody who will come with a USB stick or a disk drive formatted to Mac OS or so on. So otherwise, you will need to go back home, convert his file, and come back. We try to eliminate small steps. Sorry, if because I'm the only one who I'm my own moderator. So if you have questions, leave it on the chat, but I'll need to check afterward. We need to eliminate small steps, avoid administrative procedures. So we have a little bit of money, so we can take cash. We offer USB sticks in case somebody doesn't have, but we also have many ways to send a file to a printer. So it can be sent directly. I would like that. It could be sent to an email and afterward share between computer. What else? That's, I think, the main challenge to eliminate small steps. And I think that's the way where we can truly have improvement in the easiness of digital fabrication. Okay, that one. Uh, I've worked for long on that diagram. If you want, it's published as Creative Commons. At the bottom right, you have the URL of those files. Um, that diagram is intended to explain to the newcomer how it will take his idea from neurons to atoms, to material. So it's very abstract. First you learn that you need to do a 3D model. Okay, right, I have a 3D model now. So can I print it? No, you need to slice it before and so on. So that diagram shows where the steps he will need to do to achieve his goal. It also shows that Inkscape, a 2D drawing, vector drawing software, is very polyvalent. So you can use it for a lot of software. And currently, I'm trying to push further. You see here for embroidery, yeah, we do have a proprietary software, Premiere CQ, but since we can do that with InkStitch, it's a plugin for doing embroidery. It will be easier for the newcomer to just use one software. And if I can do that for the laser cutter, I will do it. And we can also program a CNC with Inkscape. So that's a very nice feature, and we'll try to focus on that one also. So as you see, what I would like to do is removing one of this phase. The ideal will be you take your idea, you make a drawing, 3D model, and so on of it, and then poof, you push it to the machine. But between it, we still need those translation softwares or plugin. So that's it for that. We are in Canada. So the Canada chose the metric systems in 1976, but until now, we still have a lot of people who are using the inches and so on. That's very tough. Let's say for a kid, a student, they are not used to inches. Um, we do have a lot of members who come from Europe which are not used to inches. So we decided to move to millimeters. So everything in the Fab Lab is sold by millimeters. That's the true dimensions, and that's it. Um, and we use millimeters, not centimeters and so on, because that's the unit of engineering, let's say. Uh, I often hear the argument saying that, oh, but the material also are sold using imperial units. Oh, truly, that's very interesting. But in fact, when you, let's say, a piece of wood that is called 2 by 4, which is 2 inches by 4 inches, in fact, that piece of wood doesn't do 2 inches by 4 inches. It says 1.5 and by 2.5 or some 3.5, something like that. So you use a dimension that is nominal to describe a material that doesn't do the same dimension. That's very tough for a newcomer. Uh, Often, I don't know for outside Quebec, but often when you go to hardware store, you want to prove yourself. You want the guy at the counter to understand that you are his equal. You speak the same language. You are virile. You know materials, so you'll speak inches. But I think virility is no matter in a fab lab, and we prefer going directly to something very slick. And finally, about that argument, plywood, that's quite funny. We use a lot of birch plywood, which is called often Russian veneer. And people says, oh, I'll have a sheet of 1/4. Truly? Is it 1/4? 1/4 is 6.35 millimeters. In fact, those sheets doesn't they do very near 6 millimeters. So let's conclude the Russians are metrics. So we take a round dimension and we round it on the other side to make it imperial. That's quite strange. And about the screws and so on. So you see my point. One slicer to rule them all. That's quite tough. I would like to do that with the Inkscape also. I'm trying to configure all my slicers to suit all 3D printers, use only one nozzle, retrofit the machines to 1.75 millimeter filaments. So that way I'll hope that the newcomer will have less to know about the configuration. He will be able to send a file almost anywhere. That's not true, but that would be very nice. Um, let's cut with light. Well, okay, that one's about because we need to explain a lot of things to a newcomer about laser cutting. Let's say we did a video that's here to explain the theory at the beginning of laser cutting. What is vector drawing? What is bitmap drawing? How does it works? How do we communicate the machine the settings that we want to use? So we can ship them on the on the video to at least save that work. We've tried to do some standards with RGB colors. Let's say that those colors are set for precise settings and so on. That's not perfect, but it might be easier for them. And we do have a wiki. And on our wiki, we have step-by-step instructions made specifically for our machines. So often when you pick instructions from elsewhere, there will be, of course, the most of the information will suit your Fab Lab, but often there are some parts that, oh no, we don't do that like that, we don't do that like that. So it confused also a bit the newcomer. So we tried to have that. Oops, there's something. Wiki did you do? We have a wiki, so we have instructions available near the machines and from everywhere. Um, I've recently read a book, The International Makerspace Operation by Dale Grover and Tom Root. Uh, I remember that they said a lot about make it difficult to do the wrong thing. So have the material used with the machine near the machine and so on. It sounds like obvious, but I I think we can apply that and have results with that. Provide a list of material suppliers. So if the people want to order their own materials, they will be able to, they will know where to find them. Inkscape everywhere, as I told you, I'm trying to focus on that software because it's very polyvalent. As I said, it can be used for CNC milling, laser cutting, embroidery machine, vinyl cutter, and there are a lot of plugins available. I'll do a presentation on Thursday about advanced Inkscape. It's not a course about Inkscape. It's a description of different plugins and features that are most people don't know about. About 3D modeling, that's a bit tougher. There is no software that can rule them all. Of course, there's Tinkercad. It's very easy and versatile. Everybody is very. You don't need a lot of theory to be fluent in Tinkercad. But there's a Tinkercad wall, and that wall is it's quite tough to see it coming. There are some features that are lacking on that software, and of course there is a workaround. You can do some things, and you'll be able to achieve the results you need. But you had a very nice learning curve, and from a point, pack, you have a kind of singularity that makes it very difficult to go further. And it's very tough to tell a newbie that he came, he learned Tinkercad, and unfortunately I was wrong. You should switch to that other software. Well, I don't know what to do with that. About parametric, of course, there is Autodesk Fusion 360. I don't feel confident about FreeCAD and Timony OpenSCAD, unfortunately. If somebody in the chat room did some voxel modeling, voxel is for volumetric pixels. It's the same thing as Minecraft. So as in Photoshop, you have a 2D pixel. In voxel modeling, you have 3D pixels, that's small cubes. And you can use that to do 3D modeling. It's not very common. I never use it a lot in my Fab Lab, but I would like to hear if somebody's use it and how it goes. I think it will be easier for a user. SketchUp, I like it because there are some browser-based version, the same about the Tinkercad. And also be prepared to repair STL meshes. It happens very often. People come, their meshes are wrong, and you need to help them with that. The 3D scanner trap. Uh, you know what it is. It's a huge issue. People think that they will come, there's a 3D printer, they will scan their object and pack, it will be printed on the other end. That's a trap. That's why we on purpose decided not to have a 3D scanner. We just bought one recently. So I don't like to talk about a 3D scanner because I don't want the newcomer think that it will be a way to achieve their result more easily. Because I often use that expression, what looks like a shortcut, in fact, goes through a swamp. So you think you'll save time, but in fact you'll lose your boots in the mud, and it will be very difficult to achieve your project toward. That's the same with auto trace function in Inkscape. Inkscape have a function about that helps auto tracing the feature, the bitmaps information to convert it to vector drawing. That's difficult to have the right settings, and I think the newcomers should understand at least a bit vector drawing before using those features. Two people, metal. Sorry. Now let's share. So that's it for my small presentation. As you can see, there was no huge revelation, but I hope you've learned something about it. What I want from now on is just to between us to share what you do in your Fab Labs in your workshop to make it easier to newcomers to achieve the results and make democratize digital fabrication. So, okay, there's a chat. Okay, where is it? Okay, so if somebody wants to talk, that's the nice moment. That's the right moment.
I can start if you want, Jérôme.
Sorry?
I can start. I
Hey,
can
go
be the
ahead,
first
go
one.
ahead. That's a pleasure.
Yeah, sorry about that. One comment may be related to the machines. What I found out is it's easier if you can dedicate a computer to a given machine, put the right software, the right license, connect it to the network, and they don't. And you put the screen as well, so they don't have to install any software, any license on any computer, and it helps. That's my finding.
I agree with you. In fact, let's say our laser cutter has its own computer, its own computer. The CNC has its, and so on. Each machine has its own computer, but we do have some computers that are used for versatile operation, and we've decided that even if there's a dedicated computer that is used only for laser cutting, the computers will still have all the softwares needed because somebody might need to do something, and we do that like that. We begin calling those versatile computers Swiss computers. As a Swiss knife, we want to have all the small tools to be able to achieve the product. But yes, you still need one computer dedicated to the machine. Otherwise, it will be it will be more complicated, I think.
Yeah, and even a 3D printer, my Prusa is its own, not a computer, but more kind of Raspberry thing, and I can send my files through the network to the Prusa instead of using a USB stick or SD card or whatever, and losing that. Just I prefer to use a network and send it directly.
Yeah, I don't do it currently, but it's in my 5 years 5 years plan. How do they call it in English in the USSR? Their quintennial plans. I don't remember.
Long-term plan, yeah.
Philippe, I have a question for you. I know that you've made do-it-yourself laser cutter.
Yes.
How did you solve the software issue? Did you find some kind of plugins for Inkscape that helps you work around, or?
No, first I'm mainly using Autodesk Fusion 360. My basic software, my main software is there, and I'm using a Lightburn to create things for the laser cutter, and then it goes directly to the machine embedded computer directly. I will describe you later if you want, but there's no big issue there. It's an easy one, that one.
Okay. Okay. Could be
And
nice if we.
Yeah, go ahead.
It could be nice if we could do that also with the Tratec laser cutter. That's I'm always amused seeing people said, "Well, you have your file, it's already, so I can send it." No, there's another step afterward. So if we can skip that step, it will be
and same for the CNC. I build my own CNC based on the work build design, and it is its own computer. It is Mac 3 software on it with a dedicated screen, dedicated computer. All the settings are done, and the things to do. It starts from Autodesk Fusion and it goes directly to the network to that computer, and then do it and it works. Or it crashed, but it's CNC issue. Okay, it's my fault then, not the network one.
Okay, so you never go through a 2D drawing application. You always keep in 3D.
Yeah. And it generates G-code, okay, directly from Fusion, directly 3D G-code, and then to the computer.
Okay, that's nice. I've never ever thought of that one. That's very.
Yeah, it works. It works.
I think Claire, you appeared, so I presume you want to talk.
Yeah, hi, my name's Claire. I'm
Hi.
from Australia. I'm just starting out on the journey of building our Fab Lab. So I was interested in this because I was like, oh, we are going to run into this challenge with people being very much a bit sort of, oh, what do I do when I come into this new space, given it's new for the people that are going to be using it in particular. They'll never have touched any tech like this before. Well, they might have seen a 3D printer. Lots of people see 3D printers, but laser cutters and all of that, they won't have. You mentioned about like letting them have a result on their first visit. What sort of things do you do with people? Obviously, they can't build a whole project on their first visit, and they might not even have an idea of a project. They might just want to come and learn how to use things. So, what sort of things have you found that it's like just a little quick thing that people can do? Is it, just getting them to see something done on the laser cutter, for example?
I think we can classify the newcomers into three categories. The first one are engineers, designer, and so on. So they are already initiated to almost all the theory, and they all need to learn the procedure in the Fab Lab. So for them, it's quite easy. We can toss them away. The other category that is more often on my side, of course, is the people who come with a project. That's always very easy. They want to repair a part. They need they are building a board game, or let's say a birdhouse. Often their projects are easy, but very often also there's a huge challenge. They want a plastic part that's truly transparent, that can withstand the sun outside and so on. So, oh, okay, you're going quite far. But for those, we of course we focus on their project because that's what that they wanted. And often it happens often that they get the results and we don't see them afterward. We'll try to keep them also. And for the third category, it doesn't happen that often, but we do have some often very those are kids or teenagers or very motivated people that just find the Fab Labs idea fantastic, and they want to learn everything. For them, I've begun to create a kind of uh, in French, I call that a parcours. I don't say that. The progressions of small projects, each one is a bit more complicated than the other one, and they will go with that step by step. To be honest, currently it's more a wish than a reality. We do have one project, which is the catapult. So the catapult. I don't know how.
Yeah, no, catapult. Yeah.
Catapult. Okay, great. Um, so it's cut with the laser cutter. That's nice. They see how to send the print to the laser cutter. They don't have to draw it. It's almost bricolage. I've said at the beginning that we want to avoid people doing bricolage, but that one's almost bricolage. But they've learned to how to set the machine, the security, and so on. They have a small result that's funny, so they go with it. And we want to have a progression of, let's say, 10 project per machine or type of to give them a huge idea. um, I think in Rivière-du-Loup, where we are located, we are a region where people doesn't speak a lot of English. So we do have French schools there who for Canadian speaking English speaking population who want to learn by immersion the French language. So they come there, and they have a Fab Lab cursus. So they come at the Fab Lab, and my plan was for 2020 to push them during that kind of parcours, those small steps, and to further develop it, taking the time to do two stroke with one stone. A virus changed the plan, so the English speaking population, they never came, but they will come next year, I think. So it's mainly postponed. That's for these projects. But as I told you, we we very try to have almost anything and to be able to, on a very short notice, to do almost anything. So we have all kind of plexiglass you can imagine with colors and so on. We have woods that can be cut on machines. We have screws, metric screws, of course, for those who wants to have inch screws. Let's go to elsewhere. I don't care about it. We keep a lot of electronic parts. It sounds, it doesn't cost anything almost those parts, but let's say you need a capacitor. Even if you're located in a huge city like Montreal, you'll need to do a lot of road to find your part, and often people just trying to order it, and when they order it, it comes from China, so they need to wait 3 to 4 weeks for having them parts, and it doesn't fit with the show must go on mentality that I'm trying to implement. So I'm keeping a bit of everything, selling it at immoral prices. Let's say my capacitor, I think I sold it for 50 cents. So that's very expensive considering that's a part that is worth 5 cents. But for anybody, 50 cents is nothing. They need only one, and it's very convenient to have it right now. So we try to do that. We keep a lot of old machines that people are giving us to just cannibalize some parts. It works a bit. What else do we have to make the show? We try to have different sorts of plastics, molding equipment, and so on. Yep.
I like the idea of having some like easy projects, like little projects that they can do that are simple to teach them how to use the machines. So I like that sort of idea because, yeah, there's sort of everyone's sort of like, oh, the first time I touch this thing, I'm not sure what to do. But having like a consistent sort of maybe like, yeah, having a set of little projects that they can choose from, they can kind of work through that process and learn in a way that's not too like complicated for them, and then yeah, hopefully gives them some ideas of those techniques to build the project they're actually wanting to build. So that sounds really good.
But wait a moment, Marc-André, I'll give you the parole just afterward. About let's say about the laser cutter. By experience, I see that somebody needs to do 3 laser cutting jobs before being able to use machine by himself. The first time he will come, I will do the job and I will speak a lot
Yeah.
to make him understand. The next time I say, do you remember how to do that? Let's go as far as you can do and I'll support you. The third time I stay over his shoulder and help, but usually it takes 3 times, and people afterward I have to check a bit, but that not that much. Oops, sorry, I have to admit somebody. And Marc-André, go ahead.
Sorry, I just need to turn on my my microphone. I just wanted to expand on your earlier request about talking about our different experiences on training and onboarding new users in the environment. And I have 2 different experiences on this. The first one was at the university at Concordia, which is a university in Montreal, where I teach, where we we have a fab lab in one of the innovation centers.
A nice
and
one.
So we started there with onboarding, bringing new people in, and we had a series of courses. Well, we had one course which I ran, which was called How to Make Almost Anything. Wonder where I got that idea. And I ran that for about 3 years at the university. But it was open to the public, was a non-credit course, and that went really well. Particularly, this was project-based. So people would come in with a project, and we'd have them work in teams. And in the class of, let's say, 20 or 30 students, we'd have like 10 teams working on the project. Not very successful. Very few teams actually finish their project within the sort of 15 weeks of a university semester, and a lot of dropouts. A lot of people dropped out. Then another experience in a different environment. So I work now out of a maker space in Montreal, which is called L'Espace Maker. So the maker space, basically, in French. It's about 1,500 square meters. It's the largest in Montreal. It's probably, I think, the largest in Canada last time we checked. So it's very big. It's an old factory environment. And we have like, wood shop, electronic shop, machine shop, welding shop, you name it. And including one of them, it's the 3D lab, which is what many of us would think of as a fab lab, or what you find in the fab lab would be in the 3D lab. But the whole makerspace has a lot more than that. And so, we get people who want to come into the 3D space, which is basically the space that I sort of cooperate with. We have a lead to each of the shops, right? Each of the ateliers has a leader. And so I'm sort of the co-lead of the 3D one. So anyway, the way that it's set up there is anyone can become a member. So you have to be a member of the space. You have to sign up. But you can come for a visit before, and you can sign up for one of our 101 workshops. So for example, we have, woodworking 101, metal 101, 3D printing 101, laser cutting whatever, is that you want to get into or that you see. And here, the 101, so that's the first workshop. There's a price because we want people to value it. And, we thought of making it free, but that didn't really work out well for us. It's better that there'd be a price. Like the one at Concordia at the university, it was free. And, that's why I think one of the reasons we have so many people drop out. The one at the makerspace, so if you're not a member, you can take the 101. If you decide you like it, you want to come back and use the space on a regular basis, you become a member, either, a weekly, monthly, yearly membership. To give you an idea, a yearly membership works out to about $65 per month. So that's Canadian dollars. But then you can use all the equipment inside for free, or most of it anyway. I guess the only exception would be the laser cutter because of the consumables and the lenses and stuff and the high maintenance costs. But like the 3D printers, they're all free. You can use them for free. But of course you need to supply your own plastic. So you take the 101 workshop, and that's usually a half-day workshop. In the case of woodworking, it's a little bit more. It's more like a whole day. Same as for the machine shop, because it's pretty dangerous. And then in some courses, you would need also a 102 course. So the 101 course would give you access to the basic things, and then the more advanced equipment, the 102. We don't have a 102 for the 3D printing. But then what we have is workshops where let's call them supervised workshops. So if you took the 101, we give you a key to the lab, because the lab, within the makerspace, the lab itself is locked because we have a lot of computers and equipment and all that. But once you take the 101, if you remember, we'll give you a key. You can come at any time you want. It's open 24/7. But we have certain times that are supervised workshops. So then the first things that you do, we won't give you a project. You do whatever you want. And typically, then the 3D printing, like Jerome was saying, people come in and they have this idea of this thing that they want. Maybe as a plastic part to complete something else in wood or whatever. And so we will help them with that. And so the sort of the senior maker, or the person that is running the sort of the supervised shop, is obviously someone with experience. And we're very lucky because we have a guy there who's retired, and he used to run the local shops. He used to run the shops that repaired the trains Canada was built on the train. And he was the director of the shop. He retired and he lives nearby, and he decided to become a maker. Anyway, this guy can make anything, like really like a train. Okay. So this guy is actually the guy, because he's retired, he's there a lot, and he'll work with the people and, sort of a coaching thing. And, we'll let people make errors, and we accept errors, and we have a budget to fix the 3D printers. We have a lot of spare parts and stuff. And like Jerome, we also will resell. a little bit to help people out, like metric ball, metric balls. We have a big stock of that, but also things like plastic, PLA, for example. We have a stock of PLA. We sell it by weight, and we sell it at a very high price, like Jerome was saying, because we don't want to become a store, but we just want to accommodate, the users. So that's sort of our strategy, right? Is based on companionship, but like the compagnonnage is in French, or like mentorship, I guess, in English. A companionship sounds a little weird. Mentorship, but also a basic amount of training, but really, really a very, very minimal amount of training. And then you come with your own projects. Because like I said, with my example from the university before, forcing people to have projects and to see a project through, the success rate was very, very low. The dropout rate was very, very high. The level of satisfaction from the students was pretty low as well. Whereas with the the mentorship approach of L'Espace Maker, it actually works really, really well. It's really helped the space grow. We actually, there was a few maker spaces that closed down here in Montreal because they went bankrupt, and we were able to buy out all of their equipment because we're doing well. We're a nonprofit, but still, we've been in open for 2 years now. So this model is working pretty well for us.
I took some notes while you were talking. Uh, we evaluate the idea of having onboarding sessions. It will, in fact, that's useful because sometimes people needs something to come. They needs an event to come. Next Saturday we'll have open doors. Uh, our doors are never closed. Anybody who come anywhere, we will be able to visit, but we announce open doors so some people come because that's open. So I think onboarding sessions, we need to make some. I often do that with Inkscape formation because that's easy. But on the other hand, I never say to a newcomer, hey, first wait for that onboarding session, do the onboarding session and come afterward. I think maybe it's feasible in big cities, but on our side, I don't have the luxury to lose a new member. We have a lot of members, but I always hope that a new member will become a volunteer afterward. So I don't want to lose them. That's the same with even the schedule. Say that's quite tough. Let's say if somebody works from 8 to 5 p.m. and so on, that's tough for him to find just a moment to come. So we try to have opening hours at different moments. Marc-André, I truly like your idea that every workshop, every part of the makerspace have a leader. That's a very nice idea. I think I will try to implement that idea with our members. They will be able to, I think those leaders will be able to make some decision about the growth, the next equipment they want to purchase and so on. So it might help me. It might be cool for them because they will have a true responsibility and true decision power. So I like that idea. What I forgot to say in my presentation, I think it's useful. We moved recently and we have less space, but we try to have as much as possible demonstration objects of any techniques that is feasible. Because a lot people aren't used to imagine what a machine can make. They need to see it first. So that's our plan to, we won't have 10 figurines made out of 3D printing the same and so on. It's of no use. But if one figurine is using a specific technique, we will keep it, and the other one and the other one and so on. I think it's a need. In fact, you do that because you test your machines. You know you need to know them. In fact, afterward, keep those props and make them available and seeable, viewable, well, display them, sorry. Right, the Benchy, Marc-André wrote about the Benchy, yes. I've invented a new word, I'm going to type it. It's in French, but I think if you remove the accent, you'll have the same word in English. Atelotech, it comes from the Greek imperfection, and a tech is a kind of, in French we say a library is a bibliothèque, and a collection of discs is a discothèque, and so on. That's a Greek also. And atelotech is a collection of imperfection. I think missed 3D prints are much more instructables than write the successful parts and so on. So still a plan. I'm still keeping a lot of defects just to show them, to explain them, but we truly want to make a display for each machine, just to say, hey, if you do that, you may have that, and so on. So it will help understand the process, the challenge, and I think it's funny. Somebody else, pardon, I have a huge accent, so sorry. Somebody else want to talk? Oops, there's somebody who wants to join in for this stuff. Up, hi.
Maybe something to add to your comment regarding things to show. What could be useful is to provide samples with different materials and different settings on the laser cutter, power and speed. This, I have one sheet, one letter size sheet of plywood and different kind of plastic with different settings. And it's written on the sheet. If you go that speed with that power, it gives that, and it helps.
I forgot saying it because I've thought that all Fab Labs do it,
It
but
helps.
it truly helps. It's necessary, I think. Yeah, to share, to make the visible the results of the settings and so on. Okay. On my side, I think that everything I had to say is said. So
Maybe one question for you, Jérôme. How do you manage your stock? Because okay, you sell things, but it's hard to maintain some kind of control on that. How do you deal with that?
that's a true pain, seriously, because we are in a college, so placing orders and so on, it's a bit complicated. What I say to members is that we are, as Marc-André said, we are a convenience store. We help them, but I am not the official supplier. I take a quote on the sales, and the quote is what you will find on the market. So if somebody will be easily able to buy those materials cheaper if it takes the care doing so. And I explain to people that if they come and buy all my stock and saying, oh, I've bought all of your stock, you did a profit, that's nice for your Fab Lab, I helped it. No, you didn't help me, because, well, first, we are a public institution, so the cash goes in something. I don't see it for the next year, but that's not a true issue, because if I want to reorder, the school will give me the budget to do so. But that's a lot of work to order it and so on. So the sale of materials is not intended to. We do a profit, but it's not intended for that. The profit is mainly for me to say to, let's say, a student who come. He tried something, he was honest, and he did a mistake, but I say, go ahead, take another sheet and go on. On the other hand, if he come and I say, oh, your plan is have 90% chance of failure, but if he choose to go ahead, I won't give him another sheet just because he failed. Depends of I need an honest fail. And so on. I say also to people that we may have back orders, and I don't rush for back orders. So if you see that you want that, maybe buy it right now. Maybe somebody will buy the last sheet next week. I'll order it, of course. One day I'll take some time and I'll have, but I can do that at each week. We're not a store.
Yeah.
And
Any issue with broken machines or I think they use it, they break something not intentionally and it's broken then.
they before I was before I worked for the Fab Lab, there were some signs everywhere saying if you break it, you pay it. The idea was just to no, it was written ask before using. If you break it, you pay it. They wanted to the user to just take some advice, some formation before launching his project, and to make sure that everything is fine. I removed those signs because I have a huge, nice example for that. One day, a guy came to sue his jeans. Uh, I thought he was knowing how to sue, so I didn't follow them. He broke the 5 needles we had. So he broke one needle, replaced it, one needle, replaced it. And when all 5 needles were broken, uh, he went away. So he went away frustrated because he didn't get the result he wanted. And on my side, it took me maybe 3 weeks before realizing that, oh, I don't have any needle anymore. So we'll need maybe 2 weeks to order them and so on. So from now to new members, I say, if you break something, I will never charge you. I will never. It never happened. And that's why also, let's say about milling machines, some milling machines like the Tormac and so on are a collision on those machines will cost $10,000 because you will break part of the tools and so on, and each part is expensive. But on our Shapeoko, a collision will break something, but it might goes below the 100 or 200. So I think the Fab Lab can afford it, and I prefer not to do it. But very often people are uh, don't want to break. They don't want to feel bad and so on. They break. They break a lot of things. Mainly students because those guys are brutes. Do you say brutes in English?
They just don't care.
But no, that's I don't think they are like my boy. They don't know how strong they are, and they think that, oh, if I push it, it will snap one day. You don't push it on the right side, so it will break before snapping. They need to learn it. And
Jérôme, I think for us, where I've seen the biggest issue is when people try to fix something, and that's a big problem. So we've basically made it a rule that, if you break something, you're not allowed to fix it. And you need to tell us because, we'll know, like we have cameras and everything in the makerspace. Like we know who came in, who was there at what time, whatever. So we know who it was, right? If you break something and try to hide it, then we might make you pay for it. Or perhaps just revoke your membership to the space.
There's fixing, but there's also calibrating. When people come to a Fab Lab or maker space, they consider themselves as maker or at least want to be maker. So if some things go the way that they don't think it should go, they will try to tweak the settings and do the calibration and so on. Um, Calibrating Ultimaker, just doing the bed leveling is quite a challenge, and very often they are missing the machine much more than missing the machine much more than they are helping. So usually I say no, don't do that. Take the other machine with. And when I'll have some time, I'll do it just to have it the way I want it. But that it happens very often. One day I came and almost all scissors were missing for sewing scissor for fabric. And I said, what happened? Somebody took all the scissors. I thought, they will come back one day and so on. it was a member who took them because she found that they aren't cutting well enough. So she sent them to a sharpening shop, and she brought them in. That was very nice from her to do that. But I didn't knew that she took almost all the scissors. So might have helped me, but maybe I think the day when she took them, it was a volunteer who opened the lab, and maybe she told the volunteer, and the message didn't came to me. So
Maybe one point regarding safety and responsibility. How do you manage that if someone hurt himself with your equipment, even scissors? How do you manage that?
First, I explained that security is not their matter; it's our, because we might have issues with insurance and school. Often that happens mainly with the young people. They think, oh. If I cut myself, it will be I will suffer. It will be my pain. It doesn't concern you. And no, it doesn't go that way. So I'll explain them that it might create a situation where the school might want us to add some more and so on. Um, I removed all the X-Acto, the cutters. I have one with the automatic blade that come back. And when they ask, I still have the standard cutters, but I ask them if they have some kind of competence card, and I'm trying to ask what they are trying to do with it. I have those concerns with the CNC machine, but that one is it's the more difficult machine to use in a fab lab, because you need to understand the tool, you need to understand the material, you need to understand the speed, the vector drawing, and so on. So I never saw somebody uninitiated going by himself using the CNC machine. So it doesn't happen. The glasses, I need all the time to remember people, hey, your glasses, don't forget. um, that's it. In fact, to be honest, just in front of my fab lab, there's the school metal shop and woodworking shop, and those machines are much more dangerous than mine. So, but the insurance guy won't compare. He will say, "Oh, you have a way to make it more secure. Let's do it." And that's what I'm trying to do. Our CNC has a kind of cover that you can close it. I made it mainly to avoid dust and noise, but it's mandatory to close it, and I'll add some kind of limit switch and so on. I've talked about some features to make it more secure. Um, just to avoid that the company ask us to remove the machine, saying that there's a professional grade machine all those security features, but those security features comes from $30,000, so we don't have the money to afford it.
Thank you.
I have a question for
Yes.
you. I'm in Cleveland, Ohio, in the States, and one of our dilemmas is that we have the willing who want to get involved with digital fabrication, right? And there might be the ability to get the resources to do this as well. But there's two dilemmas. On the one side, people are always asking us to worry about advanced manufacturing and 3D printing for workforce development sort of issues. On the other side, people are arguing, no, it's the more creative, the arts, and make sure you know the programming, electronics, and the computational thinking side of this. There are a lot of universities that are open to the communities, but culturally it's just totally different. You know, the kids don't feel comfortable going into these spaces. If there was one piece of equipment or one piece of advice that you could give to start a process, what would that be? Or how would you begin to think about the process? We know that digital fabrication is something that the students need. We're trying to do a leapfrogging approach by saying, we're same way with smartphones and they forget about the landlines. We're trying to say we're going to bring digital fabrication into this space But the fear from the administrations and some of the foundations is the computer lab syndrome, where some computer labs are still sitting in classrooms, 10, 15 years ago, that's still sitting there. So how would you even have us think about this, or anyone begin to approach this?
Okay, about that, I say that there is not one machine that you need to have, that's two. Then I'll explain why. First, you need a 3D printer, not because the 3D printer is polyvalent, not because that's the more useful machine. That's honeypot. People will come in the Fab Lab because of the 3D printer. They think that machine is much more powerful than it is truly is, and they don't realize that they need to learn 3D modeling, or at least they have some competence to achieve their goals. So they come from it, they come for it, they are amazed when they see it working. But afterward, you need a way to keep them coming back to your lab, and that machine will be the laser cutter, because it is fast, it is polyvalent, you can do almost anything with that. So I think the main machine to have, it's a laser cutter. A CNC will do the same job, and it will be less expensive. But the issue with the CNC is that it's very difficult to operate. Let's say about the curve. Okay, you have a saw. Okay, a table saw. Okay, you place a sheet of wood, and you cut it. The table saw will remove 3 millimeters of wood. That's the curve. Okay, so if you take afterward the two parts you get, you put them, it will be shorter than the part before being cut. That's the curve. Just explaining that a laser cutter has a curve, it's very abstract to most people. I have to do a lot of drawings just to help them understand that. And for that purpose, also I have some props just showing the diameter of the drawing, the nominal drawing, and the result with the measurements. But with a laser cutter, you can avoid taking care of the curve, because it will do the job. Also, it's easy, material aren't expensive, and it's fast. So they will come from the 3D printer. You'll do a demonstration of the laser cutter, and they will stick with it. So I have, but you don't have to buy a huge 3D printers. For $400, you'll have a very nice machines. From now on, machines that are above 1,000, I don't see a lot of uses for them, apart those specialized machines that prints metal or so on. Personally, I'm a big fan of Prusa because of the open source story. We do a lot of explanation. That's quite funny. People come to the Fab Lab, and I'll explain the philosophy of open source. And very often people say, wait, but if I open my invention, I want to do money. I need to get a living and so on. So I tell them, well, so you want to take a patent? Oh, of course, yes, I did an invention. Okay, so you'll spend $100,000 approximately on a patent. Okay, you have a patent now. And now on my side, I copy your invention. Well, what you will need to do? You will need to sue me. you you already lost $100,000, and you'll need another $100,000 just to sue me if you win, because the patent is often very full of holes. So often I explain the idea of opening, collaboration, working, and that a machine based on open source you don't have to design it from ground up. So the RepRap story is very interesting for them, and the Prusa story is even more interesting because the company is still open source. It has a huge growth. Their machines are very nice. They still have very nice features. So on my side, suggest that. About should they learn arts or programmation? I don't push that much on programmation. I would like, but often people are afraid. I think so. Those who know how to program, they do that at home, so they don't ask for a lot of help on my side. I'll give you an example that I often do because that's funny. There's a cégep near Montreal that is called Bois de Boulogne. And in that cégep, they put a 3D printer, and somebody, one of the kids did print a dildo, a huge penis made out of plastic. The story says that journalists heard about it, and they went, "Oh, what our students are doing with the cash of the state and so on." And the college fear for his image and remove the machine. And often to newcomers, I say, "Well, okay, you come in, you want to print a dildo, go ahead. I'll laugh a bit. At least I will smile, but you will come in, you will learn how the FabLab works. You will learn how to send a file to a 3D printer. So you will have learned something. If you want to push it further, I can show you how to do a 3D modeling of your tool, and we could push it even further by adding some electronics to add some vibration and so on. So there's no bad project. You want to do a birdhouse, go ahead. You'll learn. You still learn.
But of course, Jérôme, because we're in Canada, we would not allow them to print a gun, right?
That's my last taboo. Yep.
Okay,
Don't do that.
In the last 3 years, nobody asked me for that. I'm surprised because I've thought that the people will come and want to always chat about that story, but it didn't happen yet. So
okay, just checking.
Right, no,
because like you said, there's no bad project, and I agree with what you said. And I've been around, Fab Labs and makerspaces really since 2015. I opened my first Fab Lab, and what I've seen is definitely the 3D printer, right? Is a good way to catch, right? To catch them. It's a honeypot, exactly, right? To get people interested. And definitely the two things that are the most used in makerspaces, particularly in an educational setting, is the 3D printer and the laser cutter. I mean, they're the two most used. However, the 3D printer, again, Prusa, I love Joe Prusa, is a really nice guy. I was lucky enough to meet him a few times. But the laser cutter is not cheap. And you can't afford to get a cheap one, because a cheap one's like buying a used car. I mean, you're going to pay for it eventually. So a cheap laser printer, like sort of a made in China with no local vendor supporting it, is quite a problem. This doesn't mean that you have to spend 25 grand on a Trotec, but there's a middle ground, right? But it's a lot more money. Whereas a few years ago here in Quebec, in Canada, people were pushing everyone to buy Ultimakers and Tinker Printer, Tinker Pro 3D, or this company from BC that was selling 3D printers. Tinkerin, yeah. And I got into a big argument with some of the people here in Montreal at another makers Fab Lab, and I said, just buy Prussias for the price of one of these printers, one of these Tinkerin. You can buy 4 brushes. So buy 4 brushes, and you have some small maker spaces in schools, or we have one in the chalet here in Montreal called Chalet Kent, which is like in a rough, sort of rough, défavorisé. How do you say that in English? Less economically favored area of the city, which also happens to be predominantly. We don't use African American here in Canada because we're in Canada, but African Canadian, let's say, or a Canadian with I guess black skin would be the only way to put it. We don't have that same, again, we don't have the same history. I don't mean to be offensive in that comment, but so in that neighborhood, what we've done, we put inexpensive printers, Prussias, Ender 3D, and those type of machines. And then it's okay. The people break them, and we told them, hey, you break them, you just give us a call. We'll go and fix it for you. No problem. Just don't try to fix it yourself. And that really got people, in particular in this, we're talking about, K-12 environment, underprivileged, that's the word, underprivileged area. And, the 3D printer, and that got them started and got them thinking, and it got them learning, and right. And, at first they were printing benchies and useless stuff. They were, younger, like, grade 6, 7, 8 sort of age. So they weren't printing dildos yet, but but they were printing something, right? They were doing something. And, it was the hook to get them on board. Because we talked in another session, I think you were there, about, project-based learning and all that is really nice in theory. But in practice, unless it's mandatory for students to take it, most projects will just never make it even past an early stage. So, it's not really the best thing.
About the 3D printers, I wanted to add, Marc-Antoine said, hey, for half the price of one of those big machines, you can buy 2 or 4 machines cheaper. You should also consider that any machine, any 3D printer will break. Okay, so if you have 4 printers, I will bid that you might always have one that is broken or needed some kind of adjustment and so on. So
more than one.
having more than one.
In my lab, I have 12. Actually 15 now, because we got donated 3 broken printers. They were given to us broken. But of the 12 regularly in use printers, there's at least 2 that are broken, that are always broken. Not always the same 2.
For the newcomers, when they come from 3D printing, I do a kind of analogy, a comparison. I've said 3D printing currently is like having a car in 1900. I'm gonna write it down.
Yes.
The cars were existing at that period, but the Ford T wasn't invented. So if you had a car, you needed to know how it works perfectly to make it work. And you need to know how it worked perfectly because you're gonna be stuck 500 meters later and there's no garage yet. So you need to know how to repair it. Currently, even better.
In 2021, it's like owning a Land Rover. It's always broken. Any British car, Land Rover, Range Rover, it's always broken. But it's exactly the same. The thing, we're at an early stage in this industry, and we have a lot of early adopters. But the potential, particularly in the K-12 setting, the potential is to prepare the learners for the new industrial revolution, right? The digital 3.0 or industry 4.0 is what we talk about in universities, right? The Internet of Things, or the industrial Internet of Things, right? Industry 4.0. And so we need to prepare the learners for jobs that don't exist today, right? And for jobs where they're going to need coding skills, and they're going to need, all kinds of other skills, robotics and all kinds of stuff. So, the Fab Lab is an opportunity, really, the way I view it, to basically teach problem solving and to basically teach learning, how to make lifelong learners. Because that's really what we need. I also, I mentioned early on, I work also for a bank. So one of the largest banks in Canada, and that's what I do is lifelong learning, is, making sure that our people are at the most advanced level of knowledge in their field, so that, in my case, so we don't get hacked. I work in cybersecurity education. So, but this starts early on, and this is where in the K-12, if we can prepare the youth to be able to be in a position where, they'll be able to evolve, because there's a lot of things that they're going to see in their lifetime that we don't know what they are, they don't exist. But right? Just like, our parents could probably never imagine when they were our age, well, your age, not my age. I am my parents' age now. But when they were young, and the Ford Model T was around in the case of my dad, right? I mean, they couldn't imagine the internet. They couldn't imagine the kind of jobs that we have today, the kind of problems, 3D printing in the home, right? It's basically the Star Trek replicator version 1.0.
Yeah.
So
Yeah,
we
they
got
think it is. They think
Yeah,
it
but-
is. They hope it is when they come, but they discover it is
yeah,
not
but
that simple.
our job. That's why
Yeah.
our big challenge is to get them hooked. And I really think that what we're really teaching them is problem solving and learning. We're teaching them how to learn.
I would like to
And
add
so-
about I've always during my presentation I said that a newcomer that won't come back for me is a failure because you won't become a volunteer. Often in schools, people don't want to open their Fab Labs. They are making more maker space because they fear mixing kids with adults and so on. We do that in Rivière-du-Loup. We are mixing that they aren't kids, they are more teenager, 17 to 21 maybe. That's no loss. We don't lose anything at it because they will see the kids will see adults doing more projects similar to them first. That's very encouraging, and they will see often the projects that go a bit further. So it will give them the idea to go further, and it creates a kind of huge community that help me help the others. So if I have an issue that I don't have the solution, I know that I can call a member and ask him to help that student, and he will come. It's truly interesting for any members just to be asked to help a kid. So and being able to have volunteers that come from outside will make your lab more open, because that's a huge issue. If you aren't open often enough, people will just think, oh, that going there is too complicated. I need to do that between 13 and 15 p.m. like in the banks that Marc-André is talking about. So they won't come. They will say, oh, it's complicated. I will be able just to get there in 3 weeks. So I'll find another way to do my project. So we did have in Quebec publicity, advertisement about sausage Vienners, and they say, oh, that Vienners is popular because it's fresh, and because it's fresh, people are eating more of it, and that's why it's fresh. Well, somehow it's bullshit, but in the Fab Lab, the more volunteer we have, the more open we are, and the more open we are, the more volunteer we have. So I must say that COVID was very tough on volunteering, but I hope that this year we'll be able to correct that. Well, I think we are time out, huh, isn't it?
Pretty close.
Very close. Okay, shall we say something to conclude? Maybe a last question or farewell?
Come and visit Rivière-du-Loup. It's one of the most beautiful places in the world.
Yeah,
That'd be
if
good.
you want. Yes, come. You see on our website, I might open even if we are closed for just for the pleasure for seeing somebody from another Fab Lab. That's
And they have matrix screws.
Oh, that's hard to find.
to be honest, they are very difficult to find in Rivière-du-Loup. So if we don't sell them,
Even
In
in
Montreal
Quebec.
also.
So if they want to have a 1/4 20, they will find it at Canadian Tire or Home Hardware. That's okay. But M6 screw, it's quite difficult.
Check over there.
Whereas I just go down the road to the big hardware shop, and I can get that. And we've also got an electronics store that is a chain in Australia called J-Car, where you can buy pretty much like everything. So we've got that all within, 5 minutes drive of where we're setting up. So Australia's good metric. Everything's metric here. It's great.
Regarding the electronics, the point is to make the balance between buying for long term in a big amount of stock and to keep it, or to get it immediately. You order it, you get it tomorrow, but it's more expensive. This is what I do. I buy things from China and I wait to get them, and I buy special things through DigiKey and I get them the day after, but it's quite expensive.
But
It's
you know,
kind of
working
finding the
out
right
of
mix.
out of Cleveland, you're in Cleveland, right? Working out of Cleveland in the US, you know, it's probably easier to get stuff, you know, more quickly. Whereas for us in Canada, it's a little bit more complicated because everything is coming from somewhere, you know, the US, China, or where. And so it's always a little bit more complicated, and you can buy them, but in large quantity. But still, I think that's not really something that you need to focus a lot of energy on. Just having a minimum of stock, the absolute minimum, because managing that is a nightmare, regardless of. It's just annoying, and it creates dissatisfaction as well as expectations that you won't be able to meet. So I wouldn't worry about that too much. But I think if you're gonna start a new Fab Lab or Makerspace, I would definitely say the 3D printer is the thing you need to start with, and you will need to have the supplies to make the 3D printer work. And you need to have a few extra extruders and nozzles lying around, because you'll need to replace those a lot. But I think that's probably your best way to get started. And then, just get people printing stuff off Thingiverse or something like that, and doing some very simple drawings in Tinkercad, and that they could, export as an STL and print it, simple stuff, and get them interested and understand that, it's going to be a slow process. I would say in the environments that I've seen, at least a year is really, at least a year until you get a community where, you start to have a good number of users, and enough that you'll have a good number of volunteers. Otherwise, if you're very lucky like me, and you have a guy who's retired recently and who needs to get out of the house for obvious reasons, if you've been married for a long time, you'll understand what I'm talking about. And and you have a guy like that. In my case, it's a man. It could be a woman. That is going to be your main volunteer you're going to be relying on, and as you gradually grow. And for us, we've just hit not too long ago, for this Makerspace I was talking about, the 2-year mark. And now we're at a point that we have enough users and volunteers and equipment and knowledge, to really can say that we've become autonomous. So you need, that patience.
So
Thank you for that.
Okay, so I'm closing. Bye.
Thanks, guys.
Goodbye.
Bye.
Thank you, Jerome, for a great session. It was excellent.
Yes.
I hope I didn't
My
talk
pleasure.
too much.
No, that's perfect. Thank you. Bye.
All right,
Really
see you.
helpful. Thanks, guys. See you.
Bye.
You're welcome.